Hello and welcome to another quick maths tutorial. Today, instead of teaching you a new maths technique or such, I thought I'd go over a question that appeared in an A-level exam paper that uses calculus to solve, just to apply the knowledge I've been teaching you in the series on derivatives. So here we have a graph with a curve C, like that, and a line N which is normal to the tangent at C at point A. So curve C has equation y equals half x plus 27 over x minus 12, where x is greater than 0. The coordinates of point A, which is here, are 3 minus 3 over 2. Show that the equation of the normal to C at point A, which it intersects, is 10y is equal to 4x minus 27. Okay, so let's work on that straight away. Okay, so first we need the equation of the tangent to get the equation of the normal. So to get the equation of the tangent, I'm going to find its gradient by finding the derivative of C at that point. So the derivative of C is y, so we're going to say dy dx, the derivative of y with respect to x, is equal to a half x, as you know, when finding the derivative of a coefficient of x, it's just a coefficient, which is a half, plus 27 over x, and derivative of, 27 over x can be written as 27 times x to the minus 1 in exponent form. And what we're going to do is we're going to reduce the power by 1 to find its derivative, not equal, sorry. So we keep the 27 out of it, and we reduce the power by 1 and times by the original power. So we're going to times by minus 1, the original power, and then reduce the power by 1, which is x to the minus 2. And that is 27 times minus 1 is minus 27, and times by x to the minus 2, x to the minus 2 is 1 over x squared, so it's minus 27 over x squared. So that is our derivative here of C. So that's the equation for the gradient of the tangent at C. So we just need to substitute in the x-coordinate at point A, which is 3. So we're going to put that into x. So we're going to say that is equal to a half minus 27 over 9, which is 3 squared, which is equal to a half minus 3. Half minus 3. We could say that 3 is 6 over 2, so that's equal to a half minus 6 over 2, which is equal to minus 5 over 2. That's the gradient, the tangent. So if the tangent's a straight line, we know that it's in the form y equals mx plus c, where m is the gradient. So for the tangent, we'll say that y, because it passes through the point A, we can use the coordinates of A, is minus 3 over 2 is y. That is equal to m, which is minus 5 over 2, lots of 3 plus c. So we could work out the constant here if we wanted to for the tangent, but we don't need the equation of the line of a tangent. We need the equation of the line of normal, which is, the only difference is its gradient is the negative reciprocal. So it's going to be minus 1 over m of the gradient of the tangent, mt, is equal to m of the normal. And for the fraction minus 5 over 2, find its reciprocal, we flip it to get minus 2 over 5, and we want the negative version of that, which is positive 2 over 5. So you know the tangent, the normal, is going to be equal to y is equal to 2 over 5x plus c. And it also passes through point A, so we can use m coordinates and say that y is minus 3 over 2 is equal to 2 over 5 times 3, which is x, plus c, and we need to find the constant c. And so minus 3 over 2 is equal to 6 over 5 plus c. So we're going to take away 6 over 5 from both sides, give that minus 3 over 2 minus 6 over 5 is equal to c. And what that is here is if we find a common factor of the denominators 2 and 5, the common factors of 2 and 5 are 10. So that would be minus 15 over 10, and that would be minus 12 over 10, and we get minus 27 over 10 to be c. So equation of the normal, and I'm going to say is y is equal to 2 over 5x minus 27 over 10. Another way to write that, if we scale times everything by 10, we got 10y is equal to 2 over 5 times by 10, 10 is 4, so 4x of x minus 27, which is exactly what we had to do in part A to show that it is equal to. So now part B. Okay, use algebra to find the coordinates of B. So basically we need to put the equations of the line of the normal and C equal to each other to find out the x-coordinates of where they intercept using simultaneous equations. So this is in the form 10y, so I'm going to scale up C by a factor of 10, and instead of being y equals a half x plus 27 over x minus 12, we're going to say that a half times 10 is 5x plus 270 over x minus 120, which is equal to 10x, which is equal to 4x minus 27, because that is the normal. And from that, we're going to say that 5x plus 270 over x minus 93 is equal to 4x. We add 27 to both sides. Therefore, x, we take 4x from both sides, plus 270 over x is equal to 93. Add 93 to both sides. Times everything by x, and we get x squared plus 270 is equal to 93x. And I'm then going to say that x squared minus 93x plus 270 is equal to 0. That's a quadratic. It factorizes into x minus 90, x plus, and x minus 3, sorry. As they add up to negative 93 and times to make plus 270. So x is either 90 or x is 3. And we already know that's both the coordinates of where they cross. We already know the coordinate when x is 3, where they cross, that's A. But we want to know B, so x is 90 in B. So that's the first part of the coordinate of B. And we know that y is just going to be f of x of the equation, the corresponding of 90, so it's going to be 90, and we're going to put 90 in one of the equations. So if I put it into this equation here, if I put it in, actually I'm going to put it into the this one, and I'm going to say that since 90 comes out being 333 over 10, that is the coordinate of B right there. Okay, thanks for watching. I'll leave in the description a link to the exam paper, as I thought it had some very good questions, and this is a really good example of how calculus is can be asked in questions. So thanks for watching.